let it pass.
So fractions can be classified as similar and dissimilar. If you talk about similar, these are the fractions that have the same denominator. So in this case, we have 1 half, 3 halves, and 11 halves. So these three fractions here have the same denominator, which is 2. So for dissimilar fractions, we have 3 halves, 5 thirds, 13 over 7. So they don't have the same denominators. That's why they are called or classified as dissimilar fractions. Now, addition and subtraction on fractions. So for similar, for example, this one, if we the usual process of adding similar fraction is just simply copy the denominator and perform the operation. So in this case, perform addition on the numerators. So copy the denominator 2, then we have 1 plus 5, which is equals to 6. Then 6 divided by 2 can be simplified into 3. So that is an integer or a whole number. So in the second example, we have 1 half minus 5 halves. So again, copy the denominator, just minus 1 minus 5. Just do the operation in the numerator. So we have negative 4 because 1 minus 5 is negative 4 over 2. So that is equal to negative 2. Now, so we will now focus to the dissimilar fraction because our topic today is, or the discussion for today is just, I'll just going to introduce to you 3 ways or methods in solving dissimilar fractions. So the first one is the least common denominator method, or the LCD. This is usually done in the elementary grades. So I personally experience it. This is the one that our teacher taught us in the primary grades. So the second is multiplying method. This is somewhat the same with 1, but the process is different. So in number 2, we are going to multiply each term by a fraction that will lead us to the similarity or the uniformity of the denominator. So the goal here is to find a fraction that will result to the uniformity of their denominators. So the third one is butterfly method. So it is called butterfly because of the shape it creates when you solve the fractions. Okay, now let's go to least common denominator method. So we have here, for the first example, 1 half plus 2 thirds. So in LCD method, we think of the least number that can be divided by both 2 and by 3. So what do you think is the number? Can we say 3? 3 is divisible by 3, but 3 is not divisible by 2. About 4. 4 is divisible by 2, but it is not divisible by 3. So the answer here is 6. So we have this. So the LCD is 6 for this example. So the usual process is you take the LCD, and divide it by the denominator of the first term. So in this case, 6 divided by 2 and multiplied it by the numerator of that term. So 6 divided by 2 times 3 times 1, so that is 3. The same process will be done to the next term. So we have 6 divided by 3, 2 times 2 is equals to 4. So the answer here is 3 plus 4, that is 7 over 6. And for number 2, so the same process, but the difference here is the operation. So the smallest number that can be divided by both 4 and 5 is 20. So just simply divide 20 by 4, that is 5. 5 times 1 is 5. 20 divided by 5, that is 4 times 4, that is 16. So 5 minus 16 is equals to negative 11 over 20. So that's it. So let's move now to the multiplying method. Now we have here 1/2 plus 2/3. So the same example in the previous method. So I'll just emphasize how each are done, how the process are done for each method. So here, the idea is we think of a number, just like in the previous one, we think of a number that can be both divided by 2 and 3. So in this case, we can think of 6, right? So each term here, each fraction should be multiplied by a fraction that will result to the likeness of their denominator. So for the first term, we can multiply it by 3 over 3. And for the second term, we can multiply it by 2 over 2. So, okay, so we simplify. So 1 times 3, 3, 2 times 3 is equals to 6. So the idea here actually is the reverse of the reducing to lowest term. This is the reverse of reducing the lowest term. So for the second part, we have plus 2 times 2 equals 4, 3 times 2 equals to 6. Okay, so just simply add the numerator, then copy the common denominator. So 3 plus 4 is equals to 7 plus all of 7 over 6. Okay, so for number 2, the same process. So again, we think of the number, the least whole number that can be divided both by 4 and 5, and we need to multiply it by the fraction that will result to that number. So we focus on the denominator first. Focus to the denominator. So in this case, for the first term, we can multiply it by 5 over 5 and 4 over 4. Then simplifying that would be 5 over 20. So because 1 times 5 is equals to 5, 4 times 5 is equals to 20. And 4 times 4, okay, minus, copy the operation, we have 4 times 4, that would be 16, 5 times 4, that would be 20. Then again, perform the operation on the numerator. So we have 5 minus 16, that would be negative 11. Copy the common denominator. Okay. So now let's proceed to the last part, to the last one, the butterfly method. So in the butterfly method, so in number 1, so we just simply multiply this part. So 1 times 3, that would be 3. 2 times 2, that would be 4. And 2 times 3, that would be 6. So that's it. So the illustration show a butterfly figure. That's why it is called butterfly method. Then just copy 3 plus 4, that would be 3 plus 4. Then copy the denominator. So 3 plus 4, that would be 7 over 6. Then for the second number, do the same process again. So we have 1 times 5, that would be 5. 4 times 4, that would be 16. And 4 times 5, that would be 20. So then resulting to that, we have 5 minus 16 all over 20, that would be negative 11 over 20. So all those three methods or ways resulted to the same answers for number 1 and for number 2. So that's it. I hope